Chapter 7.3, Day 1, we're looking at simplifying and multiplying rational expressions. So let's review, how do you simplify the following fractions? Now I know there are a couple ways we could do it. One way that I want to do it, just because of what we're going to be doing next or in this section, is that what I want to do with 4 over 6, instead of dividing by 2 and 2 in the top and the bottom, let me break this down to prime. So 2 times 2, and this is 2 times 3, right? 2 times 3 is 6. So what we can do is divide out the common factors. So 2 and 2 cancels out, and so that's why the final answer is 2 over 3. Let's do the same thing here with 10x squared. That is 2 times 5, and let's write this just as x times x over 2 times x, and then divide out the common factors. And so we're left with 5x, and then over 1, and we don't have to write that. So in C, it's already broken down for us, so we just cancel out or divide out the common factors. And so we notice we're left with 2 over 7. So that's what we're going to be doing with some expressions. A rational expression is a fraction whose numerator and denominator are non-zero polynomials. The domain of a rational expression excludes values that make the denominator 0. So we'll be talking about excluded values. A rational expression is in simplified form when its numerator and denominator have no common factors other than 1. So let's simplify some rational expressions. So the property is, if you have A over C, or AC times BC, then what we can do is we can divide out the common factor of C, and we're left with A over B. So 15 over 65, let's do what we did earlier. Let's change this to 5 times 3. And then the 65, we know 5 goes into 65. So this is 5 times 13 is 65. Divide out the common factor. So our final answer is 3 over 13. Now let's look at it at how we're going to work with our rational expressions. We notice we have it's 4 times x plus 3, and we have another x plus 3 in the denominator. Now we can only cancel out 1, and so our final answer is 4 over x plus 3. Now just to talk about excluded values, we're not allowed to have what in the denominator? So in the denominator, it's whatever makes it 0, right? You are not allowed to make that 0, so we cannot have. So if you can solve for it, x plus 3 equals 0. Subtract 3 from both sides. So x cannot equal negative 3. Okay, and some of you can see that right away, that it can equal negative 3, but that's how you would solve for it if you cannot identify it quickly. Now let's simplify a rational expression. So when we're simplifying, really what we're going to do is we're going to factor the numerator and denominator, then we're going to divide out common factors, write it in simplified form, and then what we also need to do is identify any restrictions that we have, what excluded values we have. So let's try this first example. We need to factor x squared minus 4x minus 12. And if you need to, you can always use the x method. So what multiplies to negative 12, that adds to negative 4. And so that is negative 6 times 2. So the numerator factors to x minus 6 times x plus 2. The denominator is just a difference of 2 squares, so thinking about it as square root in the front and square in the back term, we get x minus 2, x plus 2. So we factored the numerator and denominator. Now let's divide out common factors. So we have an x plus 2 in the numerator and denominator. And now we're going to write it in simplified form. So that's x minus 6 over x minus 2. Now we need to name all of our restrictions, so what we cannot have. Now in Big Ideas, it's very particular, and it only wants you to list. So on the homework online, it only wants you to list which ones disappear. So for example, this x plus 2 disappeared. Looking at this here, the simplified expression, we would not know that we couldn't have a negative 2 looking at this here, right? We're not allowed to have negative 2. We're not allowed to have 2. So you definitely have to name this as one of the restrictions. X cannot equal negative 2 because in the original, it would make a 0 in the denominator. Now, we can go ahead and list the other one that we see. So we also can say that x cannot equal 2 as well. So what I want you to do is try these next examples. So you have 1 and 2 here, and then you also have 4 more at the top. So please try out these 6 as practice. So the first one, you don't have to factor it out. X plus 1 and x plus 1 cancel out. So it simplifies to 2 times x plus 3. Now, the one you have to name is the one I underlined in pink, which is -1. -1 disappears, so therefore name that. And then you also can name the -3 as well, so naming all the restrictions. For number 2, you have to factor the denominator. And so that factors to x minus 4 times x plus 4. And then the x plus 4 cancels out. Now be careful. So there is an invisible 1 up here. So it's still 1 over x minus 4. And then name the restrictions of -4 and 4. It might be helpful if you name the restrictions immediately. So you look at your denominator here and just go ahead and name it. So without even starting the problem, you know that using zero product property, or I think about it as using zero product property, that x cannot equal -1 because that makes this side 0, and it also cannot equal -3 because that makes this one 0. And anything times 0 makes it 0. So that might be a helpful hint for you. So if you try these ones on top, number 3, you can't simplify that anymore. There's nothing we can cancel out. For number 4, the numerator factors to x minus 3 times x plus 1, and then the denominator is x minus 3 times x plus 2. Now at this point, we can name the restrictions. We know that x cannot be 3 and x cannot be -2. And then you cancel out the common factors, which is x minus 3 here, and you're left with x plus 1 over x plus 2. And then we know that x cannot equal 3 and -2. Now for sure you have to name 3, and then -2 is also a restriction. Number 5, so a helpful hint for this one is to go ahead and factor out a 2 first in the numerator, and then factor it. The denominator, if you factor out a 4 first, the GCF, that makes it a little nicer. And then, so this factors to x minus 4 over 2 times x minus 3 after you cancel out the common factors. And x cannot equal 3 and -3. Now the one, of course, you have to name is the -3. Now, number 6, you can factor out a 2 in the numerator. Now, you notice that the x squared plus 4x plus 3 is the same on the numerator and denominator, but you must factor it out because you need to know what your restrictions are. You need to know what the values you cannot have. So you factor one of them, and you realize that it's the same for the top and the bottom. And we realize that it's x plus 1 times x plus 3. So x cannot equal -1 and -3.